We are back with some more long division practice. In this problem, you're going to see that sometimes when we're dividing, it doesn't always go into that first digit that we look at. So let's go ahead and take a look at that. So if, again, I have my reminder here of the process, divide, multiply, subtract, bring down, and repeat if needed. In this first situation here, I am dividing and I'm asking myself, does 3 go into 1? And the answer is no. So I want you to see what happens when that happens. That simply means that there will not be a number or a digit in the thousands place. Some teachers teach you to mark that with a 0, others have you exit off. In this case, right now, I am going to exit off. Because I can't go into 1, or 3 can't, then I need to grab the next number, and that number would be 15. 3 goes into 15, because I'm still dividing, it goes in 5 times. Now it's time to multiply, and 5 goes in, 5 times 3, is 15. My next step is to subtract. When I subtract, I have 0. Now I'm going to bring down the next number, which is 3. And 3 goes into 3 one time because I'm now dividing. 1 times 3 is 3. I'm at my next step is to subtract, and that is 0. My next digit is 3. That I'm bringing down. 3 goes into 3 one time. 1 times 3 is 3. And I have 0 as the remainder. In this problem, I want you to notice that because I marked off the thousands place value, that my quotient, my answer, will not be any higher than 999. In this case, it's only 511. However, it's really important to understand that these numbers don't just get put up here. They actually have a reason for why they are where they're at, making sure that we're paying attention to those place values. This 3 represents the ones place, and so does this 1. This 3 represents the tens place, and so does this 1. And then the 5 and the 5 represent the hundreds place. So as you can see, in this problem, such as the one we've done before, when I was talking about marbles being separated into 5 different groups, we can look at this problem and ask ourselves, we can really think of it the same way. If we have 1,533 marbles and I'm separating them into 3 different groups, then I would have 511 in each group. So our quotient, again, should never be larger than our dividend. Your dividend is this number here, and that is the number that's being divided by the divisor. Okay, one more problem for us to do. And this one is 3,236 divided by 4. So if we go back to our marble example, this would mean, again, that I have 3,236 marbles and I'm going to divide them into 4 different groups. Okay, so let's use our sticky note again to help us keep our place values lined up. One thing, too, before I do that, I want to point out, because my dividend only has 4 digits, which puts us in the thousands place value, that means that my quotient will never be larger than a 4-digit number. So it also means that it can never be larger than how big my dividend is. That wouldn't make any sense if I were dividing them up into 4 different groups if my quotient was larger than 3,000. Okay, let's try this. So, my question is, because I'm focusing on my dividing, does 4 go into 3? And the answer is no. And again, I'm going to block out the thousands place value. Some people, again, do like to use a 0, so that is fine as well. I'm going to move over my sticky note, and I'm going to focus on the hundreds place. the question here then, does 4 go into 32? The answer is yes. It goes in 8 times. 8 times 4 is 32. Okay, and then our next step would be to subtract, and I have 0. Okay, I have to bring down because I have a digit to bring down still. So notice I'm going to draw my arrow, and I bring down my 3. My next question is, does 4 go into 3? Now this is a little more complicated because the answer is no, and in the past when I did that, I grabbed another number. Well, that's not going to work in this case, but because I say no, I still have to have a number to represent that tens place. And that number will be 0 because 4 goes into 3 0 times. And 0 times 4 is 0. And then I can subtract. See how that works? And then I can bring down what's left, which is 6. Now, does 4 go into 36? The answer is yes. It goes in 9 times, making 9 times 4, 36. And if I subtract, I have a 0 as a remainder. So I have just given you a few examples of how to do long division using the standard algorithm. Please make sure you try some of these on your own. Make sure you can go back at any time to watch any of these again for a good refresher. Good luck.